Hi, I am Shahul Hamid, Professor ECE, working in Setu Technology, Pullur Karyapati. In this session, we are going to discuss a problem related to torque, voltage, analogy under linear control engineering. First, I will read the problem. Write differential equation governing the mechanical rotational system shown in figure. Draw torque, voltage and torque current electrical analogous circuits and verify by writing mesh and node equations. So this is the mechanical rotational system given. When you are seeing this mechanical system, you find three nodes. One node at J1, another one J2, J3, and in between J1, J2, J3, a spring dashboard are connected and torque is supplied on the first mass element, that is J1. So with this we are going to solve the problem. So here we need to consider three nodes. One is J1, another one is J2, another one is J3, and we need to write differential equations related to these three elements. Before that, so here let angular displacement is J1, displacement of J1, J2, J3 be theta 1, theta 2, theta 3 respectively, and the corresponding angular velocities are omega 1, omega 2, omega 3 respectively. So first we will take first mass element J1. Moment of inertia is J1 and torque is supplied T and angular displacement is theta 1 and opposing forces are due to the moment of inertia, dashpot and a spring. Here the dashpot and spring are connected in between J1 and J2. So the equation related to Tj1 B1 are given here. Tj1 is J1 d square theta 1 by dt square. T B1 is equal to B1 into d theta 1 minus theta 2 by dt, and Tk1 is equal to K1 into theta 1 minus theta 2. By Newton's second law, the applied torque is equal to sum of opposing torque. So Tj1 plus Tb1 plus Tk1 is equal to T. I am simply substituting the equation in this equation. I get J1 into d square theta 1 by dt square plus B1 d theta 1 by d theta 1 minus theta 2 by dt plus K1 into theta 1 minus theta 2 is equal to 1. This is the first equation. Similarly, I am going to consider the second mass element J2. Here there is no force applied and that angular displacement is considered as theta 2, and here there are four opposing forces. One is related to J2, another one is related to dashboard, then spring and another dashboard. Here Tk1 and Tb1 are common to J1 and J2, and B2 is common to J2 and J3. So the differential equation related to all these opposing torque are given here. Tj2 is equal to J2 into d square theta 2 by dt square. Tb2 is equal to B2 into d theta 2 minus theta 3, because B2 is in between J2 and J3, and Tk1 is equal to K1 into theta 2 minus theta 1. Tb1 is equal to B1 into d theta 2 minus theta 1 by dt. Now using Newton's second law, we are going to write the torque. Applied torque is equal, sum of applied torque is equal to sum of opposing torque. Here there is no opposing, there is no applied torque, all are opposing torque, so sum of opposing torque is equal to 0. So I am simply substituting the value of all these opposing torque, I get this equation. This is equation 2, that is J2 into d square theta 2 by dt square plus B2 into d theta 2 minus theta 3 by dt plus B1 into d theta 2 minus theta 1 by dt plus K1 into theta 2 minus theta 1 is equal to 0, equation 2. Then we are going to consider the third moment of inertia, J3. Here there are three forces, three torque or opposing torque, and there is no applied torque, and angular displacement is theta 3, and this Tj3 is related to opposing torque of the mass element J3, and B2 TB2 is opposing torque which is related to the dashport is connected between J3 and J2, and K3 is the spring which is connected with the reference. Okay, now the differential equation related to all these opposing torque is given here. So Tj3 is equal to J3 into d square theta 3 by dt square. Tk3 is equal to K3 into theta 3. Tb2 is equal to B2 into d theta 3 minus theta 2 by dt. By using Newton's second law, the sum of opposing torque is equal to 0 because there is no applied torque. So Tj3 plus Tb2 plus Tk3 is equal to 0. I'm simply substituting the value of all these opposing torque. I get J3 d square theta 3 by dt square plus B2 d theta 3 minus theta 3 minus theta 2 divided by dt plus K3 theta 3 is equal to 0. This is equation 3. Now we are going to replace the d square theta by dt square, that is angular displacement using rate of change of angular velocity. Okay, so I'm simply replacement wherever I see d square theta by dt square into d omega by dt, and d theta by dt is equal to omega, and theta is equal to integration omega and dt. So I'm simply replacing the terms using these assumptions. So first equation, so this is the first equation. So J1 d square theta 1 by dt square is equal to d omega 1 by dt. B1 d theta 1 by minus theta 2 by dt. So I am simply replacing with this with omega 1 minus omega 2, and K1 theta 1 minus theta 2 is replaced by integration omega 1 minus omega 2 into dt is equal to T. Likewise, I am changing the equation with respect to angular displacement into angular velocity. So this is the second equation. So I am writing this one. So I get J2 into d omega 2 by dt plus B2 omega 2 minus omega 3 plus B1 omega 2 minus omega 1 plus K1 integration omega 2 minus omega 1 in dt is equal to 0. The third equation when I am changing the equation with respect to angular velocity, I get J3 d omega 3 by dt plus B2 omega 3 minus omega 2 plus K3 into integration omega 3 into dt is equal to 0. Now I'm going to write the equivalent parameters, like so we are going to write the equivalent parameter of torque and electrical. So torque is equal to the voltage source, and angular velocity is equal to current, and moment of inertia is equal to L1, that is inductance. Moment dashport is equal to resistor, and spring is equal to capacitor. This is the equivalence. So we are going to replace the mechanical parameters into electrical parameters using this relationship. I get first equation J1 L1 d omega 1 by dt is equal to d I1 by dt R1 I1 minus I2 K1 is equal to 1 by C1 integration I1 minus I2 in dt is equal to E of t. So now we have to draw the circuit. Here inductance is L1 and in this is actually loop starting with loop, and here the capacitor C1 and R1 is common to loop 1 and loop 2. So I'm starting with the voltage source and then I'm connecting a inductor L1 and then connecting a capacitor and the resistor in series, and I'm going to put in which is, with these two this is common to loop 1 and loop 2. So this is the circuit, electrical circuit of mechanical rotational system. Okay, so similarly we are going to draw the circuit for equation 2 and equation 3. This is the equation 2 and equivalent electrical equation. In this electrical equation we have inductor. Okay, this is it's not common, and a resistor is common to loop 2 and loop 1, and another resistor which is common to loop 2 and loop 3. A capacitor is common to loop 1 and loop 2. So first I'm going to consider loop 1 and loop 2. Here a capacitor and inductor, a capacitor and resistor is common to loop 1 and loop 2, and R2, that is the resistor, is common to loop 2 and loop 3, and then a inductor is connected as in series. Similarly, third equation, so this is the mechanical rotational equation and equivalent electrical equation. So here inductor is there and a resistor which is common to loop 3 and loop 2, another capacitor, okay, and it is connected in third loop. So a resistor which is common to loop 2 and loop 3, okay, and inductor, a series with a capacitor connected. Now we have three circuits derived from node 1, node 2 and node 3. Now we need to combine all these things. For example, you take node 1 circuit and node 2 circuit. Here these two are common. I am simply joining, and when you are combining, when you are considering loop 2, loop 2 and loop 3, these two are common. These two are common, and here loop 1 and 2, these two are common. So simply I'm joining to get the final circuit. So a voltage source connected with the inductor, and two elements, that is capacitor and resistor, these two are common to loop 1 and loop 2, and again inductor, a resistor which is common to loop 2 and loop 3, then inductor and capacitor is connected in series. So this is torque voltage analogous circuit for the given problem. Thank you.